Hi friends, let's have a look at problem 2575. Find the divisibility array of a string. And in this video, we're going to explain a treatment or solution based on simple integer division or multiplication. First, let's look at the problem statement. So we are given a zero index string called word of length n consisting of digits and a positive integer m. So the divisibility array div of word is an integer array of length n such that div I equals 1 if the numerical value of word up to index I is divisible by m. Otherwise, the div I will be 0. So our task here is to return the divisibility array of word. So here are two examples. So let's look at example 1. So if we look at the index 0, so the numerical value is 1, right? So 1 divided by 10 and have a remainder that is 1, so we get 0 here. So 10 divided by 10, we are going to have a remainder 0, so we have 1 here, right? So similarly, you can interpret 101 and divided by 10 has a remainder 1, so we put a 0 here. Then 1010 divided by 10 has a remainder 0, so we get 1 here. So this is example 2. So similarly, you can interpret example 1. For example, 99, right, or 99 can be divided by 3, so we have 1, 1, right? So you can interpret zeros, so using 998. So that's the two those are the two examples. So now let's look at the constraints. First, n is bounded above by 10 to the power 5. Right? N is the length of the word, and the word consists of digits from 0 to 9. And m is bounded by 10 to the power 9 and bounded below by 1. Right? So with that said, we can look at the treatment. So here, actually, up to index I, the numerical value, let's assume it to be current. And then if we move one step further up to index I plus 1 with digit d at index I plus 1, then the numerical value will be the previous one times 10 plus the current one, right? Because you can imagine that the original one shifted to the left, right? So corresponding to multiply each position by 10, then we add this d for the least significant digit. So this is the current number, right? So assume that the dev mode of current divided by m equals qr. In other words, we assume the current number is a multiple of m plus a remainder, right? So here we are just checking to see if r is 0 or not for each of the numerical value in the process. So if we want to check the next numerical value to check if it's divisible by m, we just need to consider this one, 10 times r plus d. The reason we want to check if m is a divisor for this number, the reason is very simple, because 10 times current plus d equals 10 times qm plus r, right? This is what we assume. So then if you expand the parentheses, we're going to get 10 times q times m and plus 10 times r plus d, right? So this part is the integer multiple of m, right? So we are going to focus on this part. In other words, this expression here equals 10 times r plus d in the sense of modulo m, right? So in other words, we just need to do the computations in the sense of modulo m in the process. So once we can grasp this idea, then coding part is sort of routine. So now let's look at the coding. So we can initialize a empty array. So this result array going to hold the divisibility array. So in other words, a binary array consisting of 0 and 1s. Right. Now let's assume a current before we enter the for loop to be 0. Right. Then we're going to iterate. Right. So for digit in word. So notice that word is a string. So we're going to change it to be an integer, right? Just for convenience. Let's do it this way. And then the current number will be the previous one times 10 plus the digit, right? So now what we are going to do is going to check the remainder. If the remainder is 0, it means it's divisible, right? If not, it's not non-divisible. So we are going to check. Let's call this one current modulo m, right? So if r equals 0, right, it means that, not double 0 here, 0. It means that m is a divisor. So we're going to append the result with a 1. Otherwise, so we're going to append the result with a 0, right? So then what we're going to do, we're going to reset the current to be r, so corresponding to here, right? So next round we are going to multiply 10 and then do the digit plus the digit. So that's the main logic here, right? Then we are going to return the results. So notice that in order to fix the idea, we introduce some variables like r, like current to reset to be r. So for sure, if we want to write a slightly shorter code, that's doable. So now let's do a check. Yeah, it passes the first example, I guess. So now let's look at the generic case. Yeah, it passes the generic case. So I guess for this problem, the main point is to realize if we move towards the right, how to get the current number from the previous one, and then we realize that we just need to do the computations in the sense of modulo m. So this will greatly simplify the computation. So with that said, I guess that's about it for this video. Thank you.